The Fibonacci sequence is a list of numbers starting at 0 or 1 that takes a number at a certain point that is the sum of the previous number and the number behind it. There are many videos and articles on the web that explain better than I can, so I won't go into too much detail here, but a very brief explanation looks like this. Looking at this list going from left to right, 1 plus 0 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 5 plus 3 equals 8, 5 plus 8 equals 13, and so on and so forth. In this video, I'm going to show you how to find the number in the Fibonacci sequence 4 different ways, with the 4th way using only a single line of code. But that solution can only be used on the lower end of the scale and may not be a good recommendation for very large numbers. The problem we're trying to solve is returning the position of the number in the sequence. In this tutorial, we are going to use the number 7 for each explanation, which will give us a return of 13, as the number 13 is the 7th number in the sequence. But before we start, I want to put out a reminder to make sure to clarify that typing the solution name before the arguments in the return statement is very important. What happens when you don't do that is it will plug in the number 7 for the n, and it will throw off your results and return the wrong number. It will simply calculate the numbers and not return the numbered position on the list. In our first solution, we use an if statement to return the first 3 positions on the list, and then move on to the rest of the list and the return statement for else. If we don't specify for the first 3 numbers, it will exceed the maximum recursion depth. Feel free to type the code in your own IDE without covering that base as an experiment to see what happens. It's important to understand what makes a code fail or what's not in the code. Under the else statement, it will return the positional number 1 step behind and add it to the positional number 2 steps behind. Because the 7 is the nth number, it will only add the 2 numbers before it in the list and return the number 13. 5 and 8 equal 13. For our second example, the if statement is more detailed than the first example we covered. It covers both positions of 1 and 2. And as stated, the first 3 positions will always add up to 1. Also in the example, the else statement is not used, and we can incorporate the sum function using a comma between the positions in the list and not a plus sign. I love how versatile coding can be. There are many ways to solve for a problem. It's just a matter of what works best for you at times, or what the preferences are of the senior programmer or employer. Using a while loop in our third example isn't the most efficient way to solve, in my opinion. It's just not clear what's going on. On top of that, you're actually appending a list and just returning the last number in the list. Some may prefer this method, but I'm not crazy about it. It's going to loop through up to a certain number of times, which is 7, and then return the last number in an appended list, as indicated by the -1. For our last example, we can use a single line of code, but the recommendation would be to use it only on the lower numbers. When we get to higher numbers or positions, you'd have to find a copy of a much longer sequence, copy and paste it into the code, and then just return the positional placement by using num within brackets at the end of the list. It could work quickly for solving a simple problem or to pass a coding question when you know the absolute maximum number used within test cases. Well, I hope you found this video helpful. Thanks for watching and happy coding!